Hello, welcome to this video. In this video, we'll be looking at resolving vectors and 3D vectors as well. First one, look at resolving vectors. So resolving over vector is basically expressing it in terms of the two perpendicular components, the I and j, when we're talking about, 2D vectors. Consider a vector with magnitude r. So looking at a vector of magnitude r. This is on the ij plane or the xy plane, inclined at an angle of theta to the positive x-axis. So this is the vector that we're considering. Realize that we can extract right-angled triangle from that, where we have r as the length, since it's the magnitude. Let's call this horizontal part of the base x, and that vertical bit y. So this is theta. Now from our trigonometry, we know that the cos of theta is x out of r. Therefore, we can write x as r cos theta, and the sine of theta is y out of r. Therefore, we can write y as r sine theta. Now, we know that r, the vector, is xi plus yj from what we can see. But our x is in fact r times cos theta, and our y is in fact r times sine theta. So given the magnitude and direction, we can actually resolve the vector like this. Let's look at some examples. Say we have this as an angle of 60 degrees and a force of 20 newtons. How would we resolve that vector? Now remember, the angles we're looking at are always angles made with the horizontal. If you just check on my previous slide, you can see that theta is the angle made with the horizontal. And so we'll always be looking for the angle made with the horizontal, which in this case you can see is 30 degrees. So resolving, if we let that vector be, let's say f would be 20 cos 30 degrees I plus 20 sine 30 degrees j. Of course, all these are newtons. Now 20 cos 30 is the same as 10 root 3 I, and 20 sine 30 is just 10. So that would be your answer. Now, of course, you can write this like this to 4 decimal places. This would be 17.3205 I plus 10j in newtons. And I could also write this in column form, which is 17.3205 10 newtons. So you could write it like that. So that's how we would resolve this particular vector. Okay, say you have one where this time you have 60 degrees with the horizontal. I'm looking at 5 in that direction. How would we resolve this? Now you could look carefully. You realize that this is going to the left and downwards. If we extracted a triangle, the triangle we extract would look like that, where that's 60 degrees. And there we're moving to the left and we're moving downwards. So our vector, if I called it v, is going to be negative 5 cos 60 degrees, negative because I'm moving to the left, and then negative 5 sine 60 degrees. I write that in column form. Now negative 5 cos 50 is simply negative 2.5, negative 5 sine 60 is going to be negative 2.5 times root 3, which if you write to 4 decimal places is negative 4.3301. And so that would be our resolved vector. So even then, the directions, right, left, up or down, still come in handy. Okay, now let's look at 3D vectors. Now for vectors in 3 dimensions, we have 3 components. We have not just the I and j, but this time we have the I, j, and k. So we'll have an x-axis, we'll have a y-axis, and then we'll have a z-axis. Okay, now addition and subtraction of vectors does not change. These three axes are mutually perpendicular. So we have that being perpendicular to that and that being perpendicular to that as well. Okay, so if I have an example, if where my A is 2i minus j plus 3k, my B is 3i plus 5k, and my C is I plus j, and then D is I plus 3j minus 2k. And I was asked to find A minus B plus 2c plus D. This would be equal to, I could write this in column form. So this is 2, negative 1, 3. B would be 3. There is no part for j, so that's 0. 3, 0, 5. 2 times c, which is 1, 1, 0, I plus j. And then plus d, which is 1, 3, minus 2. So we're going to have 2 minus 3, which is negative 1, plus 2 times 1, negative 1 plus 2, which is 1 plus 1. That's going to give us a 2. Negative 1 minus 0 plus 2, that's 1, plus 3, that's going to give us a 4. And 3 minus 5 is negative 2, minus 2 again, it's going to be minus 4. So this would be our final answer, which you could write as 2i plus 4j minus 4k. So really nothing changes when it comes to addition, subtraction, or scalar multiplication. When it comes to finding magnitude, here we had the vector A, which is given by xi plus yj plus zk, and the magnitude of this vector would be the square root of x squared plus y squared plus z squared. So similar to 2D vectors. When it comes to direction, however, it's not easy to use an angle because we have three axes, and so inclination to those three axes would be hard to illustrate using angles. So what we really consider is the direction ratio, and we know that parallel vectors will have the same direction ratio. So what we're talking about here is the simplest form. In other words, if there are common factors, you'd have to reduce of x to y to z. Yeah. Okay. Now, the concept of unit vectors also applies to 3D vectors. In other words, the unit vector of A in this case would be xi plus yj plus zk multiplied by 1 out of the magnitude of A. And so we still have unit vectors. So let's try this example that we've been given using the knowledge unit vectors that we know. So we've been asked to find a vector which is 20 units in magnitude and parallel to 1, negative 1, 1. So we know that a vector is equal to its magnitude times its unit vector. Now we already have the magnitude, which is 20 units, and we need the unit vector. Now the unit vector of this vector, since it's parallel to 1, negative 1, 1, will also be the same as the unit vector of 1, negative 1, 1. Therefore, its unit vector is going to be 1 out of the magnitude of 1, negative 1, 1, 1 squared plus negative 1 squared plus 1 squared times 1, negative 1, 1. This is going to be 1 out of root 3, negative 1 out of root 3, and 1 out of root 3. So that's the unit vector that we have. Therefore, the vector B is in fact 20 times 1 out of root 3, negative 1 out of root 3, 1 out of root 3, which is simply 20 out of root 3, negative 20 out of root 3, 20 out of root 3. You could rationalize this. You could actually find what it is in decimal form. This would be your answer, and that's how we do this. Okay. In the next video, we shall be looking at vector products.